When we looked at scatter plots before, we sort of sketched a line to try to see if we could map out the pattern, either increasing or decreasing, or if there was no pattern in our data, to help us understand the type of association that might exist between our two variables. Now what we're going to look at are scatter plots that have a specifically calculated linear regression model or a line of best fit. These equations will always be of the form y equals mx plus b. And in the case that we have to the left, we're looking at a scatter plot comparing the number of faculty members at given colleges with the numbers of students. The points plotted make up our scatter plot, and this specifically calculated linear equation, which is that line of best fit, comes out to be y equals 18.4574 x plus 213.5106. For right now, we're not talking about how we come up with that model. We'll get to that. But right now, we just want to talk about the model itself. Since this equation is written in slope-intercept form, we know that the value b represents our y-intercept and implies that the y-intercept for this model is 0, 213.5106. We also know that the slope, which is 18.4574, is greater than 0. And we can see from the graph depicted that we have a strong positive association which corresponds with the notion that our model has a positive slope. So if we look at colleges with more faculty members, we're also going to see larger student populations. And the reverse is true. If we look at schools with smaller faculty sizes, we would tend to see schools with smaller student populations. In example 2, we have a graph depicting the number of school enrollments in thousands and the number of people living below the poverty level in thousands in different regions, along with the regression model, which will turn out to be y equals negative 0.4787 times x plus 20.502. In this case, our value for m, the slope, is negative, which corresponds with what we see just looking at the plotted points, a negative association. Meaning that as we look at regions with higher levels of school enrollments, we see lower levels of poverty, or fewer people living below the poverty line. Let's go and clarify that. So we're talking about the number of people living below the poverty level. So the negative slope in our model corresponds to the negative association that exists between those two variables. In example 3, we have data on the number of ghosts and UFO sightings in different regions, along with a linear regression model, which is y equals negative 0.0993 x plus 1108.4087. In this case, our slope m is getting pretty close to a value of 0. It's not quite 0, but we're getting to a value that's approximately 0. And that corresponds to the scatter plot that we see on the left, where there's no real discernible pattern between the x and y variables. As the slope of our linear regression line gets closer to 0, that corresponds with a situation where we likely have no relationship between the two variables.